For coming. Achim Hasenmüller. I recently got demoted from CEO of Innotech to Director Engineering at Sun. Maybe you've seen in the news our company, Innotech, which is the creator of VirtualBox, get acquired by Sun Microsystems. So this is actually my first presentation as an employee of Sun Microsystems. So I'm going to talk a little bit about the history and what is VirtualBox. I don't know how many of you have seen the product, have used it. Probably maybe 50-50 or so. So I'm going to talk a little bit about what it is. I'm going to talk about our architecture, how it compares to other solutions. Some of you have seen the Zen presentation just before this one. So I'm going to compare it a little bit where it is different. I'm going to talk a little bit about virtualization technologies, what different kinds of virtualizations are there, where do we fit in, and where we see the industry is going. And then mostly I'm going to talk about what is our roadmap for VirtualBox, what features are we working on, and where do we see the product in the future. And then I'm going to talk a little bit how we work with the community, because we are an open source project and we do a lot of work with the community, and how the acquisition through Sun is going to impact this. So just to warn you, I'm absolutely new in the job at Sun, and of course we're still working out many details, because now at Sun, of course, we have very different opportunities, very different possibilities. Now, we used to be a 22-man engineering shop in Stuttgart, Germany, and now we're a 40,000 people company. So there are, of course, new opportunities we have. So VirtualBox, if I want to describe it in one slide, I would say it's a very comprehensive x86 virtualization platform. So x86 implies that it's not ARM, it's not Itanium, and not Spark. It's x86, and that's what it will remain in the future as well. We're extremely cross-platform. So we're not an operating system of its own like Zen, which basically has to sit beneath what you're running as a workload. This is also called a Type 1 hypervisor. We do have a Type 1 version of VirtualBox, actually. I'm going to talk about it. But we're mainly used as a Type 2 hypervisor, which means you have your operating system, Linux, Macintosh, or Windows. You install VirtualBox just like an application. It's a bit more than an application, but it looks like an application to the user. So we support a very large range of platforms. And the main ones being Linux and Windows, that's where we currently have the product in the most recent version and always the same time. Macintosh and Solaris, they're still in beta phase, so we're still trying to feature complete the ports. And there's also a FreeBSD port. That's more a community effort. We do not make official releases of that one yet, but I really hope that we will get everything going so we can also officially support FreeBSD. And there's no reason why it cannot be ported to other platforms. There's not a community effort. It's been ported to the IBM OS2 operating system. That's really funny. I think there are like 5 users left. And one is here. Okay, I used to be an OS2 user as well. So VirtualBox actually been written to target all different use cases of virtualization. You might know it as a desktop end-user system today, but it's actually been written for something else. It's being used for other things. It's just not being marketed in a community way by us through these other users. So the technology has been designed that it spans from end-user to embedded systems. This is where most of our business has been. Up to the high-end server consolidation, which is where we currently are not, but we have technology to be there. I'll explain a little bit about how it was created so you understand why we have certain focus points. So there are 3 major things we put emphasis on. And the first thing, I think this is the biggest differentiator to all other technologies on the market, is that we are extremely modular. So we have building blocks, modules that you can compose the product. Our biggest competitor has, I mean, I'm talking like a company that had to make money, because that was our situation until we were acquired. We had to bring in the revenue to keep this thing going, the open source product. So we're faced with competition. This was mainly VMware, and they have a huge portfolio of products. You know, there's Player, Workstation, Fusion, Server, ESX, ACE. It's all around the same hypervisor, but they have a huge portfolio, and they have thousands of employees to maintain that portfolio. And we're small group of developers, so we had to come up with an architecture that could allow us to address all these different use cases with a single source code base, because we cannot maintain like 10 repositories. And one of our goals, you know, this was how we wanted to win the hearts, is to put a strong emphasis on user friendliness, on user interfaces. So we had, like, in the beginning, 30% of our development resources on user interfaces. And I think this was a very good move. This is how we've gotten a lot of adoption. So we have around 4.5 million users now, the ones that we count from our downloads. And we're also part of Debian and OpenSUSE, and we're on cover mount DVDs, so it's hard to count the exact number. But user friendliness, it's been our key to get to the people's computer. And security, this was actually our first main market. I'm going to talk a little bit about this. So the security aspects of design were like really key in the beginning when we designed the whole architecture. So we have a dual license model, maybe similar to MySQL, and surprise, surprise, we're now in the same company. So we do have our source code under the GPL v2, which we provide as source code tarballs, which is also part of Debian Linux and OpenSUSE. And we also have our binary package, which come under a proprietary license. But that license allows for free of charge use in almost all the cases. So most people actually that code to our website, they take the binary package. And there are a couple of features which are not published as source code, because this has been our business model in the past. Remember, we didn't have any funding, no university, no venture capital, nothing. So we had to earn the money. That's why we have this dual license model. And I think there might be some adjustments in the future, but that has not been determined yet. So I think like 95% of our code is GPL as well. So just quickly about the history, where we come from. So we actually started virtualization in 2001. Maybe you've heard about Kinectix Virtual PC, which is now Microsoft Virtual PC and Microsoft Virtual Server. The next version is Microsoft Hyper-V, which is still similar technology, same team. So we actually contributed to the virtual PC hypervisor back in 2001. And in 2003, we sold this to Microsoft. So we sat there, we had a great business, and it was really fun working in virtualization that early, and then everything was gone. So we sat down and thought, what can we do with all this knowledge? So we actually started to develop our own hypervisor from scratch. I call it third generation because first generation, I think it was VMware. They were the first on the market. And second was Virtual PC on x86. So we learned a lot. So we thought, how can the next architecture look like? That's why we came up with this modular approach, because this what we found was the biggest issue we always had with the Kinectix hypervisor, was that it's not modular, that it was a big product, and there were not easy ways to customize it so that third parties can embed it and develop their own. Like, you want to develop your own virtual hardware. You do not like our virtual network adapter, you want to have your own. Neither VMware nor Microsoft, they provide you with the APIs to do so. And so in the early days, back then no one knew about VirtualBox, because our focus was entirely on the government security market and embedded systems. So we've actually, there's a very comprehensive security architecture maintained by the German Federal Agency for IT Security, BSI, that's called SINA, Secure Inter-Network Architecture. This is the standard architecture based on Linux, which is used for government agencies in Germany to process confidential classified information. And you know, you might believe it or not, but even the most classified information nowadays is being processed on Windows systems. In order to protect that, the use of virtualization was discovered as being a very good way to sandbox a Windows system. You know, you might have a Windows system that has very confidential information, but if you sandbox it, like it has no way to go to talk to the outside world, it's actually a secure environment. So this is what we mainly done in 2005, 2006. We were not open source at this point. We've always planned from 2004 on to go open source, but you know, there's a nice analogy. If you put a frog in a cold pan and you heat it up, the frog will stay and die. But if you put a frog in a hot pan, the frog will immediately jump out. So we thought, instead of starting with version 0.01, let's first get something done that really works well, that people can actually use for a lot of things, that is not alpha level, and then release it. So that was our strategy. That's why in 2005, 2006, there was nothing from us that you could publicly download. So then 2007, we actually went GNU public, and we released it, created the virtualbox.org community. We spent a lot of time preparing that and understanding how the community works. It's a very different way. You know, if you want to integrate something in a commercial operating system, you talk between business people. But if you want to get something integrated into Debian Linux, you have to really understand how they think, and you have to follow their policies. So that required quite a lot of preparational work. And the Debian was actually quite hard. So they found lots of issues, and we had to address them, every issue, and until none was left, and then we were integrated. So then the latest one, February 2008, was actually Wednesday this week when the transaction closed. So we're now officially part of Sun Microsystems. So we have now sister projects like OpenOffice and MySQL and OpenSolaris. So there's a lot of virtualization out there because it's really a big topic in the industry right now. The first one, application virtualization, is quite old. I mean, this is now being used for what Citrix's been doing for many years, that you just take an application and you remove dependencies that the installer of the application creates, so you try to abstract them so you can deploy applications in a very easy way. Softricity is the technology that Microsoft acquired recently. That is also called virtualization nowadays. And another thing which is also very old, I call it container virtualization. On Linux, it's like a change root environment or BSD jail, or in Solaris, it's actually called containers. So this is like you have an operating system on the server, and the operating system can multiplex itself to the applications. So the applications, when they query a list of processes, they will not see the processes in the other change root or container environments. So you actually only have one. You just have one operating system, but from an application point of view, we can actually separate them. So like in the Sun world, you can run actually run Linux applications in a container, or an application that needs older libraries in a different container. It still doesn't allow you to deploy an operating system the way it is into a container, but it gives you a lot of the advantages of consolidating workloads on one physical system. Then there is para-virtualization, where Zen is the best known example. So this is actually multiple copies of operating systems on one system, but these operating systems, they have been modified. So they do not talk to the hardware or to an emulated hardware that they think is real hardware, but instead they talk to a para-virtualized interface. So they talk to the hypervisor. Now, instead of writing to a register, they make a call to the hypervisor. which means those operating systems, they have to be modified to actually do that. And also, you need to define this paravirtualization interface. It should be a rather stable interface, because otherwise operating system vendors have to adjust it all the time. And so Zen is like the best example, because paravirtualization gives you really good performance. You don't have to use any tricks to emulate things. The operating system just goes straight to the hypervisor and makes a call. And then there's the full system virtualization, which I put in bold because this is where we are, this is where VMware is. I'm going to talk a little bit more about how these things actually converge in the future. But full system virtualization is you take an operating system the way it's been. Maybe you take Microsoft OS 2 1.2, we actually have that running, from 1980 something. It has never been written to run in a virtual machine, but you just install it the way you've done on a physical machine. So you do all the work to emulate a full PC so that the operating system does not have to know where it's running. And this is really, really tricky. Maybe you've heard this about some old DOS computer games. Their algorithms broke when the CPUs got too fast. Because their timing algorithms, they made some assumptions about the CPUs that were broken many years ago. So if you want to, and that's just one example, there are hundreds of these cases even for Windows operating systems. Windows 2000, if the virtual IDE controller is too fast delivering interrupts, Windows will reboot. So you have to actually make it buggy in order to make unmodified Windows work. So full system virtualization is a very tricky business, and it typically comes at a certain cost because you have to go through very complex algorithms to emulate everything correctly. So those are a couple of building blocks from our architecture. I said earlier we're put a very strong emphasis on being very modular. So most of these blocks are actually their own files. Now if you install VirtualBox, you will see there are quite a lot of files in there. And those files, they usually talk to each other using a documented API that we do not change all the time. And the idea is that you can create your own blocks. And we have a lot of customers that have built such blocks. Like the easiest example is probably the virtual devices. You know, like a VMware, they always have a PCNet adapter. We also have a PCNet adapter. They have the VMware graphics adapter, an Intel PIX4 controller. You might want to change that. We actually have a binary compatible interface. That's also very important for us to be binary compatible, because even though we are open source as well, we still believe in having binary compatible interfaces, because it's just much easier for someone that uses this rather complex piece of software that they write their device and they don't have to understand everything. They don't have to follow the development all the time. They can just develop this device. It has a versioned interface, and it will continue to work. And because we've done this as a business, we also have those support agreements. So it's in our interest that these things continue to work, and we don't have to deliver support. One example with one customer, which is Siemens, they have developed a virtual PCI card that represents one of their industry bus controllers for their factory automation devices. So all they do is they develop this shared object, and then they, in the configuration of the virtual machine, they say PCI bus add device contained in shared object profibus.so, and then it gets loaded and automatically pops up on the PCI bus. So that is one example of the modular architecture. And on the bottom you find our hypervisor, which is typically hosted nowadays. We do have a self-hosted version, a type 1, which is also originally developed as a prototype for the military customers. So there will be more on the self-hosted type 1 side in the future. But typically, in most use cases, we are hosted. We have also a component that is pretty unique in the industry. That's our own RDP server. So from the very beginning, we wanted to have good remote control. And like the Microsoft hypervisor, the connected was based on VNC, which was, back then kind of slow, and in order to make it faster, you had to change the protocol. It was no longer compatible with VNC clients. So we said we want to take a protocol where everyone has a good client, and it turned out that RDP is a protocol that is sufficiently documented, thanks to our desktop team. They have taken the ITU specification, figured out the undocumented bits. So our desktop is on every Linux system, the Microsoft RDP client is on every Windows system. So everyone can basically access our virtual machines remotely. And this is actually one of the components that is not open source as of now, that we have closed source. And on top of everything, we have an API layer. I'm going to talk a little bit about that. So everything you can do with a program, with VirtualBox, you can program. Typically, it's C++. It makes use of XPCOM, the Mozilla component library, or COM on Windows. And on top of that API, we have everything else, like our user interface of cross-platform GUI, which is written in Qt 3.3. That one exclusively talks to our API layer, only to this one layer, not to anything below. And same goes for the command line interface and now the web services API. We found that most people nowadays, don't want to program C++, they want to do SOAP-based web services. So we created a web services API. It's an incredible overhead, but if you just want to do things like start and stop VMs, it really doesn't matter. You don't want to, transport the frame buffer SOAP encoded in XML. No, we actually, I was not aware how inefficient web services are. So we generate, I think, 3 megabyte of source code is generated, and GCC takes like 2 minutes to compile that file. But it's really simple because you just import that description into your Eclipse, and then you can, program it just with mouse clicks. So it has some advantages, sure. So how does our virtualization actually work? How does it compare to Xen, to VMware? So until a couple of years ago, the Intel and AMD CPUs did not have anything special for virtualization. Yet it was possible to do it at good speed. VMware brought out the first product in '99. It was already quite good back then. The reason is that the x86 instruction set has a couple of design flaws that make it very difficult to virtualize. You can basically say the main issue is that some instructions that should be privileged, like they should not be allowed to access from a user mode, they are allowed to be accessed from user mode, or what's even worse, their behavior is different. And that really makes it very hard to do virtualization, so the algorithms are extremely complex. So the way VMware solved this is for user mode, it's okay because user mode stays user mode, but the guest kernel mode you have to actually deprivilege because you don't want to have it to have the right to access the real hardware. So what they've done is they rewrite all the code that is in the guest kernel. So they analyze it and recompile it. And that is really difficult to do because the x86 architecture is so big and so complex, and there's so many side effects in the architecture. And once you start rewriting code, you have to rewrite all the code because then all the memory addresses change. So this is really difficult to do. And with now with VTX and AMDV, you don't have to do that any longer. But still, it's not a perfect world because the hardware virtualization turns out to be significantly slower than an efficient software virtualization. It's gotten better. Now, the first one was in the Pentium D, and now with the latest systems that have VTD, the 45 ones, it's gotten much, much better. But there's still, in most use cases, there's a significant difference in performance. And also, if you are Xen, if you're server-oriented, this might not be a reason, but we're actually very focused on the embedded market. There you don't find these extensions yet, like on the VIA CPUs or in the entry-level AMD CPUs, even the entry-level Intel, the ultra-low voltage. My Sony VAIO does not have VTX, and it's a brand new laptop because it's the ultra-low voltage CPU, and there they saved a couple of transistors for that. But the main reason is actually performance. So VMware does not make use of hardware virtualization in most cases by default. You can enable it now with the current version, but it only makes use of it by default if you run a 64-bit guest on an Intel CPU, because their classical way of virtualization doesn't work in long mode on Intel CPUs. It works in AMD because they made some adjustments for VMware, but not on Intel. So there they use VTX as of now. VirtualBox does both actually. So we fully support VTX and AMDV, but our focus is on software mode. So you can enable it. Maybe you've seen it in the user interface, and you actually need it if you want to run more exotic guest operating systems like OS2, which makes use of certain rarely used CPU architecture features of the Intel CPU, like call gates and a lot of 16-bit mixing. There we actually require it because we never bothered making our software mode clever enough for these exotic cases. So we have both, and Ian already mentioned it. Both have advantages, and if the hardware vendors they do that job well, then at one day everyone will use the hardware features. But as of today, there are still plenty of reasons to not do it. So para-virtualization, I mentioned that this means you have to modify the guest operating system so it doesn't talk to the hardware, but it talks to the hypervisor. And if you look at the industry, what is mostly deployed, I mean, the clear market leader it's basically a monopolist, is VMware. If you really go out to customers, there's pretty much only VMware in the classical virtualization. And this is full system virtualization, but what I think the biggest trend right now is to combine the full system virtualization with para-virtualization. On Linux, they started with the para-virt-ops. Maybe you followed the Xen integration into the Linux kernel. This was a really long process because the modifications that are required for the para-virtualization, they're quite complex and large. So with full system virtualization, you basically have the standard kernel and you make a couple of small, Microsoft created that term enlightenments. It's a good one. So it basically means the operating system, the guest operating system has some knowledge about the hypervisor and does some things in a more efficient way. So VirtualBox has actually been using those enlightenments for years, but from the other way. So our technology, it's very different actually from VMware or all the others. We have like a dynamic optimizing compiler in VirtualBox. So when we get those, what typically happens if you run an unmodified guest operating system, it tries to do something with the hardware, which you do not allow as a hypervisor. So you get a trap. You look, what does it want to achieve, and then you emulate the behavior. So first of all, getting such a trap is quite costly. That can easily cost you thousands of CPU cycles. And secondly, emulating that behavior might be also rather costly. So what we do whenever we get such traps, we look at the guest, so at the assembly code of the guest operating system. We see what is it trying to do, and then we try to dynamically patch it. So we try to para-virtualize it. So the next time it does the same thing, it will no longer call to the real hardware. It will no longer cause a trap. It will execute para-virtualized instructions that talk to our hypervisor. One example is the virtual interrupt flag, which is one of the biggest challenges of virtualizing unmodified operating systems. This is kind of tricky to do this because, especially on Linux, where you have a monolithic kernel, the complexity can be everywhere, right? You can have system-level code. The lowest level code is quite large, and also Linux makes heavy use of self-modifying code. And we had real trouble getting this to work in a very reliable way because Linux tries to optimize certain routines based on the CPU it finds. So it patches itself during boot up. And self-modifying code is we modify the guest code, and then the guest code looks at itself and modifies itself. That is really, really complex. Windows, fortunately, doesn't do this because Windows has this hardware abstraction layer. And also Windows changes very rarely. Every couple of years, they make a new version, which creates a lot of work to support. But in Linux, there are so many distributions, so many kernel versions. This is taking us a long time to make work in a reliable manner. And also, this doesn't have academic grade because this is not 100% bulletproof, this approach. It's bulletproof as to the guest cannot have any impact on the host operating system. It cannot crash the machine. But it's not bulletproof as to it will run everything correctly, every kernel version. So this is more an approach, more compromise, because it actually gives you great performance. There have been a lot of performance comparisons lately, VMware against VirtualBox, against Zen, against Parallels, and so on, Microsoft, and we've achieved pretty good results in those tests. So for a lot of use cases, we're by far the fastest. Not in every use case, of course, but this is a very efficient way of doing it. And one of the reasons why we did it is because we did not have the time, the funds to come up with a recompiler like VMware did. Because this is even a lot more complex to write this. So the last one I mentioned, the classical prioritization interfaces are extremely complex, really. And operating system vendors, they do not like to make such complex modifications. So it's much easier if you say your operating system is basically the way it is, and it has a couple of code paths where it takes a different path when it's on a hypervisor. And that's exactly what VMware has proposed with an interface called VMI. That is, in Linux, it's basically paravirt ops and some connect glue code that talks to the VMI interfaces, which is a BIOS extension. So a VMI-aware kernel just queries the BIOS for VMI. And if it's there, it will not call to the APIC, and it will not use STI, CLI, but it will instead make those BIOS calls, which are in fact hypervisor calls. This is a really elegant interface. So it's in the current VMware product, and it's supported by recent Linux kernels. I think it's in the latest Red Hat 5, Enterprise 5. So I really like this interface very much. And the other one, of course, is Windows Enlightenments. Just because it's Microsoft, it's probably going to be very important on the market too. So I hope that these two will be the ones that have to be supported in the future. I mean, Zen is working on supporting Windows Enlightenments, and so are we supporting those two. The first one will be VMI. So what do people use VirtualBox for mostly? The first use was actually sandboxing security. And this is a very special market, which was just allowed us to, because no other company is there, you need to go through a lot of certifications, code audits with the government agencies. But it's really very useful because in those, in the typical military, if you have those military joint missions, like you have your national system, you have an EU system, you have a NATO system, and you get classified data according to the 3 different systems, which basically means you need 3 computers. And with virtualization, you can just have everything on one laptop. And on the same laptop, you can also browse the web, which was never possible on a military system before. So all in one laptop, this is really a great use of virtualization. And it's being used by the German government. It's currently the mission in Afghanistan. It's being used. Dutch government works together with the German one on this, and some Eastern Europeans as well. This has been a really great project for us. We learned a lot about security there. And another big use of VirtualBox is just the classical operating system migration, right? Another one of our government customers, the German embassies, they migrated all their 12,000 systems from Windows to Debian Linux, but they need to continue some visa application to use some visa applications. So they just use VirtualBox, old version of Windows, no support contract. Every time they close it, all the changes get discarded. So they don't care about security updates any longer, and could cancel all the support plans and focus on the Debian platform for new applications. And another thing is embedded devices. I mean, if you go to like ticket vending machines, you will mostly find that those are standard PCs. Like the ticket vending machines of Deutsche Bahn in Germany, those are all running Windows NT 4. You can imagine how hard and expensive it is to get hardware on stock that is supported by NT 4. So using virtualization, what you can actually do is you take, let's say you take a Linux kernel, you take the virtual machine, and then you take your existing ticketing application on NT4, and you can deploy it in a more flexible manner. Right? You can actually change your hardware. You don't have to put the hardware for the next 20 years in stock. And embedded devices, that's where we are quite strong right now. You don't see those. I mean, there's one device from the French company Bull. It looks like an iPod. It's a hard disk with hardware encryption, and you can run an encrypted Windows directly from that disk. It uses VirtualBox. You don't actually see those uses because that's what embedded is. You don't see what is actually inside. Another large use case for our software is disaster recovery. Which is basically like server consolidation, but only in the case of a disaster. So you have your dedicated servers, and when one server crashes, the same image is started on another server in a virtual machine until the hardware is replaced. There we have large installations. And last but not least, desktop virtualization. VDI is what the term that VMware created, so that you actually have your desktop PC, mostly Windows, and you run that in a data center and you access it remotely using a thin client, or you can actually roam it and things like that. This is why we created this RDP server, and we've been doing this for many, many years. Funnily, together with IBM. So now that we are part of Sun, that's also interesting. Couple of more just interesting things, I think. So I think our seamless windowing support is a very interesting feature. You maybe know that from the Macintosh. Actually, the first company that done that, it was Connectix Virtual PC, had it in the late 90s. And now Parallels picked it up, and VMware picked it up with Fusion. So currently, those vendors, they only have it on the Macintosh, but we have it in a cross-platform way. So you can have your individual application windows on your GNOME or KDE desktop, even on the Solaris desktop. It's truly cross-platform. And we're now working on making this the other way around, so that you can actually have individual Linux application windows on other systems. I know it's already possible with X, but that's not so straightforward to set up, and having an X server on your typical Windows or Macintosh system is also more difficult to do than just use our seamless windowing feature. And something I'm very proud of, but basically no one actually sees, is our internal API layer, where we have this really large API. It's object-oriented, and you maybe know that C++ is not a good way to expose APIs, because the C++ binary interfacing is compiler dependent, and even compiler version dependent. So if you want to link with a library, it better be compiled with the very same compiler as your application. So there are ways to make this work, and this is Microsoft COM, and Mozilla has actually followed this route, and they've created something called XPCOM, cross-platform COM, which is like a clone of COM. And we use COM on Windows and XPCOM on all the other platforms, and we've created a lot of software that allows us to write one source code and have both COM and XPCOM being used automatically. And we've also had to extend XPCOM quite a lot, because it was more limited to single process model, which Mozilla is. So we've done a lot in the out of process, because we have multiple processes that talk to each other. So you need to do like IPC, serialization, deserialization, stuff like that. I think this is a really good piece of technology which other projects could use as well. And there's now, last summer I went to Boston, met with Miguel from the GNOME team, and we discussed Mono and XPCOM integration. That would be really good. I would really like to create a Mono layer on top of our API, and that's actually being done now. There is an XPCOM bridge for Mono, so all our APIs are accessible from Mono. .NET provides this anyway, COM access, so that's something we want to add. There's also one thing, when we did the GUI, we actually spent a lot of time thinking which is the right technology to base our GUI on. We knew that Windows is the most important platform in the market, so we better be a 100% Windows application. And so the question is which platform to use, because we don't want to write a GUI for each platform. So we actually came up with Qt. We didn't like the license, we didn't like some aspects of it, but it was the right choice, and still today we would have to make the same choice, because GNOME applications on Windows, they are not 100%. They might be 90% now, but there is not 100% Windows application. But the thing is, we're still in Qt 3.3 because Qt 4 has never been widespread on the Linux system. For Windows, we compile Qt, we ship a DLL, but for Linux, we actually require Qt to be on the platform, on the system. And so we're now having a discussion, when is the right time to migrate to Qt 4? So I'm open to input for there. Some people tell me now most distributions have Qt 4, because you cannot easily migrate. Qt 3 to Qt 4 migration is like almost a rewrite. You have to touch like over 90% of your source lines. The real motivation to migrate to Qt 4 is because Qt 3 doesn't give you really good Macintosh Aqua applications. So the Macintosh support is actually only good in Qt 4. But I'm not happy with Qt, I've never been, but I don't see any alternative. That's why I'm bringing up this. It's really hard to get a good GUI library that is cross-platform and native looking for all the platforms. So where do we want to go in the future? What are our next goals? Of course, we want to increase our market share on the desktop. We're now at over 4.5 million counted users, which is already a significant share of the market. We've won some good, we've received some rewards recently, and but we want to actually follow that, deliver more features, give people absolutely no reason to buy products like VMware or Parallels. We want to reduce the number of closed source features. Maybe we even manage to eliminate them. I would like to do that. But our old business model was just based on being able to generate revenues on selling licenses. So we're working on the details, how this can actually be more open at Sun. And of course, we want to extend our development team. So we're roughly 20 people right now, which is not a lot compared to VMware. So I think the lines of code per developer actively maintain our companies like at least 10 times higher than VMware. So we're trying to extend the development team, of course. And we want to start to promote it for different uses in the future. It's been in different markets, as I showed, but we've never actually been promoting that widely. So now the roadmap. This is actually quite long, because we have great plans. So currently we're at 1.5.6, was just released a couple of days ago. And that's the third maintenance release of the 1.5 branch. So we've been on the 1.6 branch for many months, but it has a lot of new features. So we've been continuing to maintain the 1.5 branch. So what's new for the next one? It's already there, these features. So if you take the SVN build, you will get these. It might not be 100% stable or 100% done, but it's everything is there already. So we've greatly improved scalability. We have one large server deployment on a Blade server with 8 cores and 32 gigabytes of RAM and 96 VMs of Windows XP running at good speed. And running at better speed than competitors. So we've made some great advantages, great movement in scalability. The web services will be in 1.6. Increases compile time significantly. So the Debian guys will probably disable it. There's a feature, memory ballooning. I really dislike that feature because I don't think there's anything you can replace memory with. Memory can only replace by more memory. Memory ballooning means that you allocate memory in a guest as a helper process, and then you give it back to the hypervisor. Because every operating system, Windows and Linux, when it sees 1 gigabyte of memory, it will use the 1 gigabyte. It will use it for cache or for whatever. It will never leave memory unused because that would be stupid to not use memory. So with ballooning, you actually discipline the operating system, because the operating system doesn't know about the others. So it doesn't know that the others actually need all the memory, and it will happily increase its cache during that. So with ballooning, you can actually tell it to not do that by allocating memory and then giving it back to the hypervisor. But it has a lot of, because people tend to overcommit machines. And if you really overcommit machines and then you get Microsoft Patch Day, then actually your server crashes, or but at least you get downtime. It's easy to reproduce. We've created an Intel Gigabit virtual device emulation. It's the most over-sophisticated piece of hardware I've seen the last couple of years. It's almost like an IBM token ring card. It's really complex. But the thing is that Vista doesn't support the PCNet, and also it has some features that can improve performance in the future. So with the current VirtualBox code, you can actually select Intel Gigabit card instead of the PCNet. And this is, I think, one of the greatest new features no one else has. We've written a serial ATA controller with native command queuing, and this will significantly improve performance for storage because we can actually handle many I/O requests at the same time. So we're going to further continue exploiting improvements to VTX AMDV. I already mentioned that we do the seamless windowing for Linux. And we want to finally get OS X and Solaris to finishing those two. This is more for the future. I'm not going to go into detail there. Everything we have there, we've already partly done. It's not just ideas. There's code for every single of these. But we're not there that I can say, it's done in 2 weeks. But the most important one is currently 64-bit guest support, so we're actively working on that one. That will be available hopefully before April. Yeah, one interesting thing, we have our own disk format. It's called VDI, but we've started to support VMDK from VMware. You don't have to convert it. You can just use it. And we actually want to replace VDI by VMDK in the future. Just make use of that industry standard file format. VMware has recently published the specifications to this file format. So currently we don't do snapshots and things with VMDK, but once we do everything, we want to make use of it by default. Okay. And of course, we're working on Solaris guest editions. Been doing that for a while, actually, but now we really should get it done. Yeah, so community, we have the typical website mailing list, forum, IRC, and we work with the packagers. If you go to a website, there are like over 20 packages for Linux distributions. There are 2 for Windows and like 20 for Linux, all the different distributions. And we really like to support all different Linux platforms, even if the percentage market share might not be large. And for contributions, there's one thing. We don't accept GPL contributions because we still want to have the rights to close source certain parts. But we also do not require a copyright assignment. So you have to sign a contribution agreement, which just gives us the rights to use it. It doesn't take the rights from you, like a copyright assignment. The alternative is that you just put your contribution under MIT, which is what most people do. Okay, I think we're pretty much done. And if there are a couple of more questions, 3 minutes. Yeah. Well, actually, there is USB support, but that's one of the closed source features. And we plan to open source the USB support as the next one. But there is full USB support, and there's even now USB 2.0 support as of version 1.5.4. So it's just not open source yet. But that's my next on the list to open source. Yeah. Well, that's interesting. I try to raise this issue. I'm not married to Qt. I think the license is not good and other things as well. But GNOME is not an alternative in my opinion because of Windows. So I think GNOME on Windows should get better. Then we could actually use it. I think right now there's no alternative to Qt. The only question is Qt3 or Qt4 in the future. The fact that Qt4 is so incompatible to Qt3, I also think this is terrible for us as an application writer. But that's one of the things that keep me awake at night. Which GUI library to use? We started using WX widgets, but we didn't like that very much. Okay, so one more? Okay. Well, I tried to show that there's no impact at this time. So it is really Sun's intention to keep VirtualBox alive I mean, we are a separate development lab within the Sun organization. I report to the vice president for Solaris Core operating systems design, who is responsible for hypervisors, and Sun has a couple of hypervisors. So we are going to remain quite independent as a development lab. So we're just going to continue VirtualBox. We're going to continue the open source model. So as of now, I'm not aware of any changes. Of course, the first change I realized is that we are now bound to US export law. So we need to filter IP addresses if they are from North Korea and things like that. That is the only impact we've seen so far. But the intention really is to continue doing that. I think similar to OpenOffice, which has remained very independent over all these years. Okay, so thank you very much.